once. You guys didn't, was it this class that said that in the past you actually had to make your unit circle yourself? Okay, it sounds like some of you do is make you make one. We're not making you make one, so we passed one out to you. So you might notice a couple of things. Just take a look at the unit circle, so the very front circle. We're going to get to that other stuff not till later. So you just really need to look at that front circle. Anything you guys notice about it? It is a circle. Yep, got it.
It has degrees.
All right, the degrees and the radians are listed. So if we take a look at, let's say 45 degrees, it also has pi over 4. So it has degrees and radians listed. So for the degrees featured on the circle, you won't have to do your conversions back and forth. That's kind of nice. Anything else you guys notice about your unit circle?
Zeros on the right.
Say that again?
Zeros on the right.
Zeros on the right side. Okay, we'll talk a little bit more about that today. So that's a good observation that zeros on the right side. If you go back to the 45 degrees, wait, actually I want to do a different one. Let's go to 60 degrees. When you see 60 degrees, you see the coordinates that go with that 60 degrees. So we'll talk more about those coordinates today as well. One of those coordinates is actually cosine of 60 degrees, and the other coordinate is sine of 60 degrees. So that'll be in your notes a little bit later today. But then if you go to 120, so if you compare the coordinates for 60 and 120, what do you notice?
The first one's
One of them is negative. What's the same about them?
same.
Like they're like the same numbers but like different signs, right? If you go down to 240, do you notice it's kind of the same thing? The signs are switching, but our numbers are the same. And same thing with, I think, 300. So notice that there's a pattern to those numbers as we go around the circle. Plus, like if we think about the numbers 60 and 120, they're kind of connected as well. We'll talk more about those connections a little bit later. And like the signs differences and all of that stuff. But again, I'm hoping that you guys, have used this before. So a lot of this stuff I'm not going to go very slow with because you've done it before. And there's not a whole lot of examples either because you've used this before. So we are going to talk about the unit circle and the trigonometric ratios. And on Monday, the section is applications of trigonometric ratios. So we will talk about that then as well. Like, keep going. We don't have a stat box on today's. I think we just forgot about it. So sorry. We don't have a stat box. So there's our unit circle. It's the same circle that I gave you, and the reason why, we'll go to that in a second. We've got our center right at 0, 0 on our coordinate plane, and the radius is 1 unit. So we can see that to the right it goes out to 1, going up on the y-axis goes up to +1, left is -1 on the x-axis, and going down is -1 on the y-axis. So we've got that radius of 1 as we go around that circle. So that's our basic little unit circle there. Did anyone notice I know I already put mine away, but did you notice it was like 30, 45, and 60 on that unit circle I gave you? Yeah, those special right triangles sneaking back from geometry and trig. Okay, so this is pretty much the same stuff as the last one. The general equation for a circle is x squared plus y squared equals r squared as long as the center is 0, 0. So we've got the center is 0, 0. Again, this is basically the same picture. This is more general because it just has r listed. But for our unit circle, r is 1. Keep in mind that we've got a point on our circle that is related to our angle. We've got those x and y coordinates there. Can you say that again? Oh, it's just like a European spelling. Like meter sometimes is R-E, theater. What color has the U in it? It's just like a European or English, like England English. It was taken out of your textbook. Okay, so this is the actual equation for the unit circle because the radius is 1. So 1 squared is just 1. So there's the general equation. This is the equation for that unit circle. This is just some stuff that we're just refreshing your memory, hopefully that we talked about that in geometry a while ago. So just kind of refreshing your memory on some of that stuff. We're going to talk more about how the angles work coming up next, and then we'll have some trig identities and things as well. So here we go with the angles. I'm going to switch this symbol a little bit here. Usually we use like the theta, like yesterday, for a positive angle. And I think in the textbook with the whole it being international, they say anti-clockwise. We usually say counterclockwise, right? You know what I mean when I say counterclockwise? Okay. So if you don't like saying anti-clockwise, you can say counterclockwise. So when we have our angle, and so that's why 0 is on the right, is so if we start like right here on this x-axis, we're going to go around the counterclockwise. That's a positive direction. That's a positive angle. And then usually use like this symbol. It's very similar. It's another Greek letter called phi. A lot of times we use that for the negative direction. So if I'm going around counterclockwise, it's positive. If I'm going around clockwise, it's going to be negative. We're going to have an example on the next slide that puts some numbers to this so you can kind of see how it works with numbers as well. And again, I'm hoping you guys are kind of coming back to you from last year or the year before, whenever you took trig. And most of the time we use the positive angles, but just so you know, just make sure you go that counterclockwise. So here's an example. So our positive angle theta is 210 degrees. So we start here, going all the way to here, that's 210 degrees. And then we go negative from here to here, that would be negative 150. Why do you think they have that little arrow of 30 degrees? Like, why is that there? Okay. So they like the angle from the x-axis. How big is half of that circle? 180, okay? So if you think about it, 180 plus that 30 degrees, that's that 210. So that's kind of where it's showing us, okay, from here to here is 180, add that 30, you got 210. Same thing with the negatives. We know that this is 180. If I subtract that 30, because I'm not going all the way up to 180, 180 minus 30 is that 150. So you might see some like other clues on your picture to help you come up with that. And there's going to be a lot of different relationships that are based off of that semicircle at 180 degrees. So we'll take a look at that a little bit more moving forward too. If you have a question, please let me know. Again, I'm going a little bit fast because it should be mostly review. But again, with the international textbook, maybe something's worded differently. So don't be afraid to ask a question if you're like not quite sure about what's going on. So here are some pretty important things. So sine and cosine are related to our unit circle because the cosine of the angle is the x-coordinate of the point. Sine of the angle is the y-coordinate of the point. I don't want to zoom this in too far, but I'm going to circle this in red. It kind of helps right here. The P just stands for point, so don't let that freak you out. But the x-coordinate is cosine, and the y-coordinate is sine. That y looks like it looks a little weird. So that means you look at your unit circle and I say, what's the cosine of 60 degrees? You can just look at this, see that, oh, the x-coordinate's 1/2. The cosine of 60 degrees is 1/2. You don't have to pull out your calculator and use that. In this case, like the example I'm giving right now, so you can go right to here and find that information. So is everyone okay with sine and cosine? I would say that's a pretty important thing to make sure you do have in your notes. SOHCAHTOA is always really good to remember. We'll get into that more later, like not today, but more later on. What does that T stand for? Tangent. Does anyone remember the relationship between sine and cosine and tangent?
Cosine over sine.
Close. Opposite reciprocals.
Sine over.
Sine and cosine are opposite reciprocal, or are reciprocals, not opposite. Yes, write this down. I know we didn't have it typed up, but the tangent is sine divided by cosine. This is like a really important one to remember, but as I say remember, that's in your packet. It is. So I just noticed a lot of students forgetting that, or like, again, it's in your packet, so you don't actually have to memorize the tangent is sine over cosine. For me, I always like stutter for a second, and I'm like, is sine on top or is cosine on top? Like, I need to like take a moment, but it is in your packet. It's right under the formulas we had yesterday. So the formulas we had yesterday with the arc length and the sector area, with the radian angles, right underneath that it says tangent of theta equals sine of theta over cosine of theta. So like, if I said, what's the tangent of 60 degrees, it's not so easy as like looking, there it is, but you know how to calculate that. You've done that before. Another really important one that I feel like people forget too much, and this is going to become one of your best friends over the next few months, is the Pythagorean identity that cosine squared plus sine squared equals 1. That one is also in your packet too. It's like the next one underneath. So you've got your arc length, your sector area, you've got the trigonometric identity, which is the tangent, and then you have the Pythagorean identity. So 2 from yesterday, and those 2 in red are all in your packet as well. Again, a lot of this should be review. Any questions so far? Okay. Let's see. That's fine. We don't really need to get into that right now. Let's see what's next. Oh yes, I always forget about this. I think that you guys might have said something a little different. There's kind of like something to help us remember stuff. You know how like PEMDAS, like please excuse my dear Aunt Sally. So a couple of ones that the book suggests is that all students take calculus. I don't think that's true, so I don't love that one. All silly turtles crawl. I believe you might have heard a smart trig class. Yeah? Okay. So like that's another one too. So we've got a couple of things. It goes like this. I'm going to see if you can figure out what it means. And if you want to come up with your own, you can. Last year my students came up with their own little phrase, but it was sad, so I'm not going to tell you. But
What was it?
it was sad, so I'm not going to tell you.
Why not?
Because it was sad.
What if it helps us remember?
We'll see. Maybe you can come up with it on your own.
Like, was it like sad, like poor, or like saddening?
Saddening. Like, tear. Okay, so here's how it goes. If you look at your unit circle that I gave you, look at quadrant 1. We all know this is quadrant 1, right? That's like an algebra 1 thing. You should notice that everything is positive, right? So it's all positive in quadrant 1. That's what the A stands for, all positive. So if you look at quadrant 2, cosine's negative and sine is positive, right? So that's what this one stands for, that sine is positive. We're going to skip quadrant 3 for a second and go to quadrant 4. So if you look at your unit circle in quadrant 4, do you see that cosine is positive and that sine is negative? So that's quadrant 4. And when I'm saying this, I'm saying that like we know, we just talked about it, that it's cosine, sine. So our x's and our y's, like that's what I'm referring to looking at your unit circle. Like if you look at that unit circle, your y coordinates are positive here. Here your x coordinates are positive. Here it's all positive, right? So this one, everything is negative. So what does the t stand for? Tangent. Because what we just talked about is that the tangent is positive, and since tangent is sine over cosine, if it's negative divided by negative, it's going to be a positive. So that will definitely help when you're trying to figure out the signs of what you've got going on. So like, what's positive, what's negative. So the All Silly Turtles Crawl, or A Smart Trig class, helps you remember, okay, A, all, S, sine, trig is actually tangent, and then cosine. So it's to help you remember what's positive where. It's just, like I said, it's like PEMDAS or something like that, just to help you remember. I mean, I don't think I said this to you guys yet. That unit circle that we gave you, like you can use that. That's kind of like your formula packet. Like I'm not going to take that unit circle away from you. Okay, so you can always look at that too. Like if you forget this, it's kind of easy to see right on there. Okay, so you're going to have a lot of examples that you can look right on your unit circle. But this one we won't be able to, so I'm going to help you kind of work through this one because 132 degrees and 48 degrees are not on like that unit circle, but we can still use the unit circle to help us figure it out. So it says, find the cosine of 132 degrees if we know the cosine of 48 degrees is 0.6691. So again, this one's a little bit more difficult than just straight looking at your paper, but we can still use the unit circle to help us figure it out. So for me, I feel very visual about this, and like I need to draw myself a little circle. Maybe you can do it all in your brain, that's okay. Where would 48 degrees fall? Like what quadrant would 48 degrees fall in? Quadrant 1, right? So, 45 is right there, so probably a little bit more. So that's 48 degrees. I should probably put that on the inside, but that's okay. Why do you think, like, what's the relationship between 48 degrees and 132 degrees? Like, what's the connection between those two numbers, anyways? Okay. This is acute, that's obtuse, but what'd you say, Michael? Yeah, it does equal 180. If you're not sure, you can just tally it up. Sure enough, 180. So then, this cosine of 32, well, 132, sorry, it's going to be less than 180, so that's going to be somewhere over here. So all the way over here is that, 132 degrees. Do you remember we talked about how, like, there's a relationship? That's at 48 degrees. I know the green's not super easy to see, but that's the relationship between the two, is that they're like symmetrical, right? So that's the thing that's kind of neat about it, is they're connected. So that 48 degrees, I know that the cosine is 0.6691. I just put it like, I don't know what the y is, it's irrelevant right now. But, irrelevant was last week's ACT word. Okay. So if this is 48 degrees and my cosine is 0.6691, over here my cosine is still going to be 0.6691. Again, the y part's irrelevant. But thinking about it, is cosine positive or negative in quadrant 2? Cosine's negative because cosine's the x-coordinate? That's okay. Remember, I know you've done this before, but I'm not asking you to be experts when you walk out the door. So that's where we know that this is sine only. So cosine is going to be negative. So the cosine of 132 degrees is negative 0.669. So definitely look for those connections. I'm not going to give you numbers that like have zero connection to them. Okay? Like, I'm not going to give you something that has no connection. That wouldn't make sense. So look for those kinds of connections. This is one of those assignments or those sections where you kind of got to get into it, get into the assignment, check your answers, practice it, and that's how you're going to get better at it. So we don't have a bunch of other examples. There's more of like, okay, get to that assignment, see how that goes. Okay, I know this looks long. Well, I wish I could just make things a little bit bigger, but it doesn't work that way. So keep in mind, for 4A, you don't have to do all the parts, just those parts, but you do have to do 4B and 4D. 5A is kind of the same. You only have to do those parts, but you do have to do 5B and 5D as well. Now, if you look